Hello everyone. This is our video solution to problem 3 from quiz 6. And in this problem we are asked to set up an integrated triple integral to find the mass of a ball. We're given the density function. So we're just asked to set it up. We don't actually have to compute it. And one of the reasons for that is that at this point all we have is the rectangular coordinate system. Well, of course, in class we introduced cylindrical and spherical coordinates, which will actually be better for computing this sort of triple integral. But for the purposes of this quiz, we are still just working with rectangular coordinates. And so the computing the integral is possible. It's just going to be a little bit hairy. So we're going to stick with just setting it up. So the first thing to note is because we're trying to find the mass of a ball, and we're given a density function, we know we can compute that with a triple integral. Let's just quickly write that triple integral down, not as an iterated triple integral, but just as a triple integral. So the mass is going to equal the triple integral over, well, we don't actually have a name yet for this sphere. How about we'll call it S, right? So S will be the sphere of radius 3. Okay, so we're going to triple integrate over S, and we're going to integrate the density function. Okay, which was this guy right here. All right, so that's the triple integral we need to compute and or at least set up here. And so we're going to now write this as an iterated triple integral. To do that, we're going to have to write down S explicitly. So S, remember, right, this is a sphere of radius 3. In fact, we know exactly which one, so one's centered at the origin. So we could try to draw a picture. So, okay, there's our best attempt at quickly drawing a sphere. And maybe you have some coordinate axes coming out of there. There's a z-axis, there we had an x-axis, and heck, let's get a y-axis going out of there. And we know these are all hitting at 3. All right, cool. So if I want to write down S, there's a pretty standard way to do this. If I'm writing it in rectangular coordinates, which again, definitely not the easiest way to write it, but I can start by first projecting this entire sphere into the xy plane. And if I do that, all of these points, right, they're going to go straight down into this disk in the xy plane of radius 3, right? Also things from down below, right, they'll move up here as well. All right, so all of the xy coordinates anywhere on this sphere live inside this disk in the plane, which we could call that D, right? So the sphere is S, and D is just this disk in the middle. Okay, now what do we know about the Z coordinate? Well, the Z coordinate is going to be somewhere on the sphere, or maybe down beneath it, right? You might have stuff in the middle. And we can actually solve for the Z coordinate. We can use this x squared plus y squared plus z squared equals 9, solve for z, and well, we take a square root at some point, and we're going to need both a plus and a minus because, well, we need the top of the sphere, that's the plus, and a minus, that's the bottom. So we'll have plus or minus root 9 minus x squared minus y squared. So if I choose any particular point in the xy disk, and I go up to where it intersects on the sphere, or down to where it intersects on the sphere, I know that my z's, right, they can be anywhere in between those, and the one on the bottom is given by the negative of the square root, and the one on the top is given by the positive of the square root. And so my z coordinate is going to lie in between negative root 9 minus x squared minus y squared and positive root 9 minus x squared minus y squared. Okay, so now let's write the d down, because all we said so far is that xy has to lie in this disk. So this disk we can write in multiple ways again, but how about we start with the x coordinates? So we know that, I wrote it over here, but this is actually where it intersects. Right, there's your 3. We know it goes out to 3 on this side, and, well, of course, it's got to go to the opposite, right, negative 3 on the other side of the disk. So my x coordinate is going to go anywhere between negative 3 and 3. All right, now maybe it's a little difficult to figure out what's going on with the y coordinate if we draw it flat, but why don't we rotate it up? All right, so here's our disk of radius 3. All right, so we have a y and an x axis, and we know it's intersecting at 3 and 3 here. Okay, this is a disk of radius 3. It has an equation. It's x squared plus y squared equals 9, 9 being 3 squared. All right, if I want to know the y coordinates at any point along the x-axis, I just need to know, okay, it goes in between the top and the bottom of this disk, which is given by this equation, so I can solve for the y. And just like with the z, I'm going to end up with a plus or minus. So the y is going to be plus or minus root 9 minus x squared. All right, the plus again corresponding to the top half, the minus corresponding to the bottom half. And so our y is going to go between root 9 minus x squared and positive root 9 minus x squared. Okay, of course we could toss all this into one, but usually it helps me at least to think first about projecting down into the sphere, down into the xy plane, and then we handle that later, right? Just handle the z in the first try. All right, well, now we can set up our iterated integral. So the mass, again, is equal to this triple integral, which we can rewrite as an integral where x goes from negative 3 to 3, y goes from negative root 9 minus x squared to positive root 9 minus x squared, and then z goes from negative root 9 minus x squared minus y squared to positive root 9 minus x squared minus y squared. And then we have our density function. All right, what was the density function there? I guess our density function was x squared plus 3y squared plus 4z squared. And then we'll have, we read them backward, dz, dy, and dx. Okay. And again, if we wanted to actually work this out, it's very reasonable. I mean, we could do it, right? It's going to be a mess, and it's much better, we're much better off probably doing it in cylindrical or even better spherical coordinates. Okay, but for this problem, all we need to do is actually set it up, and that's actually the hard part. I mean, we could also just give it to Wolfram, right? Why not? But the important part is Wolfram isn't going to know how to set this up. That's where we have to bring our big brains. Okay, all right. That was the last question for this quiz. We'll see you all on the next one.